Hello everyone. In this video we're going to be solving a factorial equation. Factorial equations are fun and I made a couple of videos on those. I'll share the links down below. So we have 1 over n minus 1 factorial minus 1 over n factorial equals 1 over 8. I know what you're thinking. At this point you're like, this is so easy. I can do this with my eyes closed in 5 seconds. Okay, that's not the point. I'm just going to show you a solution method for these kinds of problems and also a graph at the end, which is kind of interesting. All right, great. Let's go ahead and take a look at it. We have 1 over n minus 1 factorial and 1 over n factorial. So why not make a common denominator? Don't factor anything. Let's just make a common denominator. So we're going to multiply the first one by n factorial and the second one by n minus 1 factorial. So the numerator is just going to be the difference of those two things divided by the product of the denominators, right? Like this. And this is equal to 1 over 8. Now here's what I'm going to do. I'm going to expand n factorial and then factor this out. So write the n factorial as n times n minus 1 factorial minus n minus 1 factorial. By the way, for those of you who are not familiar with factorials, n factorial is basically defined as 1, 2, 3, dot, 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 all the way up to n. So that's the kind of like the product of consecutive integers 1 through n, or n through 1. Anyways, so let's go ahead and divide this by the product. And here's the multiplication symbol. And here, n minus 1 factorial we can take out. And then inside we're going to have n minus 1 because we have an invisible one here, right? N minus 1. And at the bottom we're going to have n minus 1 factorial times n factorial. And this is equal to 1 over 8, but I'm going to write it later. N minus 1 factorial cancels out because n minus 1 factorial is never 0, right? Even 0 factorial does not equal 0. By the way, 0 factorial is equal to 1. A lot of people are surprised by this, but there's also a proof which we can talk about later. Anyways, so we got the following. N minus 1 over n factorial equals 1 over 8. Let's go ahead and cross multiply to get a better expression. From here I get n factorial equals 8 times n minus 1, which is 8 times n minus 1. I guess it's better not to distribute because I'm going to simplify this a little bit more. So let's go ahead and expand n factorial and write it as n times n minus 1 times n minus 2 factorial. I could stop at n minus 1 and then put a factorial sign, but it wouldn't help me because I don't have n minus 1 factorial on the right hand side, but I have n minus 1. So I do need a factor of n minus 1 to simplify this, okay? That's why I didn't stop at n minus 1. Now n minus 1 hopefully does not equal 0 because that would indicate n equals 1. But if you look at the original problem, n equals 1 definitely is not going to work because we have this at the bottom. So n equals 1 is not allowed anyways. Okay, we didn't say it, but hopefully that is understood. So n equals 1 is not going to work in the original problem. So here's what I'm going to do. I'm going to cancel out n minus 1, get rid of that, and write this expression as n times n minus 2 factorial equals 8. Nice. 8 is an integer, so that's good. Let's go ahead and isolate the factorial. So a lot of times with these problems, it makes sense to isolate the factorial. Now, what do we have? We have a rational function on the right-hand side and a factorial on the left-hand side. If we're talking about integer solutions, which we are, of course, then 8 over n also needs to be an integer. Not just an integer, but a positive integer because n minus 2 factorial is always positive, right? So how can 8 over n be a positive integer? N must divide 8. So n can be 1, 2, 4, or 8. There are 4 possibilities. So how do you find n from here, or which one is going to work? Well, if n is 1, then n minus 2 factorial is going to be 8. So this is also true for n minus 2 factorial. It can be 1, 2, 4, or 8. But think about all the factorials. Like 0 factorial is 1. 1 factorial is 1. 2 factorial is 2. 3 factorial is 6. Right? I mean, did I say 8? Oh, okay. 3 factorial is 6. 4 factorial is 24. 5 factorial is 122, right? 120, I mean. So 1 is a factorial, yes, that works, sort of. 2 is a factorial, so these are factorials, but 4 is not a factorial because there's no factorial between 2 and 3. Maybe 2.5, but we're looking for integer solutions, and I'll show you on the graph what happens if n is not an integer. But if n is an integer, then 4 and 8 will not work. So those are the only possibilities. So question is, if n minus 2 factorial is equal to 1, n minus 2 is either 1 or 0, right? Because 0 factorial and 1 factorial are both 1. But if n minus 2 is 1, n equals 3, and otherwise n equals 2. So if n is equal to 3, 3 does not divide 8, so it's not a feasible solution. But n equals 2 actually is a divisor of 8, so that could work. But if you replace n with 2 on both sides, you get 0 factorial equals 4, which is obviously false, so n equals 2 is not a solution. So what do we end up with? The only thing that's going to work here is what? Let's go ahead and explore right here. N minus 2 factorial is equal to 8 over n. So we tried 1, it did not work, right? If n is equal to 1, it didn't work. N equals 2 gave us 4, it didn't work. N equals 4 gave us 2, and that is going to work. You know what? Because if n is equal to 4, you get 2 factorial equals 8 over 4, which is 2, and that is the only solution to this equation. Let's go ahead and take a look at the graph. Obviously, if you graph n factorial or anything like that for integers, you're going to get dots only. They're not going to be connected. But if you think about the gamma function, you can definitely, that's something that you can definitely look at, the definition of gamma function. And you're going to see that you have a continuous graph. And our line y equals 1 over 8 actually intersects this interesting graph very many times. You don't see the whole thing, but it's just going to keep intersecting. And you're going to have infinitely many solutions that are not integers. But the only integer solution is going to be at n equals 4. Okay, so let's go ahead and take a look at the gamma function, and we'll just finish up. So here's what the gamma function looks like. This is from Wikipedia. It is defined as, n minus 1 factorial, but it is defined on positive, not just positive, but it's defined on the real numbers. And here's the definition of our gamma function as an integral. So you can read this for yourself, but I'm just going to go back to the graph and finish up what we started. So n equals 4 is the only integer solution to this equation. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.